Okay, so this is 2022, paper 1, question 8. Quite a fiddly question. So to start with, we're asked to find this value here. This is the place where this curve equals 0. So we're asked, where does that function equal 0? Now, yeah, we know that, sorry. If we're asked, where does a quadratic equal 0, we just know that it's when x is minus 2 or when x is 5. And we do the same thing here. We've effectively got two brackets here. So I'm going to ask, when does that equal 0 and when does that equal 0? So when does that equal 0? Well, that's when t is 25. When does that equal 0? I e'd both sides and t is 0. Well, I already knew that one, didn't I? Because it's already 0 there. So that means that t must be 25. Okay, that's the first part. So we then are asked, sorry, I'm flicking around here, to show the maximum speed of the car occurs at this place here. So we're talking about this value here, and so it's a turning point. We're looking for the turning point, and to find the turning point we need to differentiate. What I've got here is a product, so I'm going to use my product rule where this is my u and this is my v. Okay, so here we go. I set up my little windows and differentiated, and it started off looking quite horrible, but actually it's not super bad because this differentiates to make that, that differentiates to make that. Remember the product rule, v du by dx plus u dv by dx gives me this. It would be a whole lot easier if we had a common denominator, so I multiplied top and bottom of this by t plus 1, so just t plus 1, and I'm looking for a turning point, so this is a formula for the gradient, so I'm just asking when does it equal 0, and because 0 is your friend, so the next thing I can do is multiply by t plus 1. And from here on in, it's algebra. So I've got to keep a view, keep in my mind what they're after. So I'm thinking I need a 26, I need a denominator of 1 plus t plus 1 plus ln t plus 1. That's got to be in my mind all along. So the expression, sorry, keep flicking around, the expression here is t equals, and I've got an ln t plus 1 there. So what I need to do to this expression is, apart from the ln t plus 1, I need everything with a t on one side so I can then factorise and get that t on its own. So that's a technique that we've talked quite a lot about. So I move this term and that term to the left-hand side. I have to say at that point I realised that I could divide by 0.4, so I divided everything by 0.4, so that term just becomes that becomes that becomes that, and 10 divided by 0.4 is 25. And now I can factorise this side here, so it doesn't look very nice, does it, because of this, but yeah, so this is t times ln t plus 1 plus 1. If you multiply that out, you get that. And the reason I do that is so that I can then divide both sides by ln t plus 1. Now, that is an expression for the time, but it doesn't look like the thing that we are asked to show. It's a 25 and not a 26. We've got the denominator right, but we haven't got a plus 1 there. And so this next bit is a trick that it's one of those things that it's really good it's sort of cropped up, because I don't think we've covered it in class, and it's a good one to go through. So this is my starting point, and this is my finishing point. Okay, so that's what I need to get to. There's nothing wrong here. So far, everything we've done is correct. We've just got a little bit of algebra to do. So excuse me while I fiddle around with my... So I've rewritten this just as 25 minus ln t plus 1 on the top, and I've flipped that around for no other reason than it's that way round in the show that bit. Okay, and at this point I'm thinking, oh, I wanted a 26 and I've got a 25. Where have I gone wrong? Well, this is a trick, because all I'm going to do is I'm going to write 25 as 26 take away 1. And then here's another trick. This is minus 1 times that, isn't it? So I'm going to write it like that. So minus 1 minus ln of t plus 1 is minus 1 plus ln t plus 1. Now, I've got here two things divided by one thing, which I can split. It's the reverse of what we do when we add two fractions with a common denominator. So I can have that as one thing minus that as another thing. Now that over that is just 1, so I get minus 1, and that over that is 26 over 1 plus ln t plus 1, which is what they were after. So it's fiddly algebra, and how did I know to write 25 as 26 minus 1? Well, it was just that was what we were asked to write it as. So it's fiddly, but it's one of those things that now it's cropped up in a practice paper. Hopefully we'll be able to have a go at it. I'm sort of assuming the iteration bit is fairly straightforward after that. So you just you do 7 equals, so 7 is your answer button, and then you just type in that, where that use the answer button, and you do it 3 times, because the first one is T1, so you do it 2 times, so T2, T3, but then this is where you just keep doing it till you get the same answer to a specified level of accuracy. Now the mark scheme uses 3 significant figures. They've used 3 decimal places, so I would have kept going until I got the same answer to 3 decimal places, and I would have stopped there. I'm assuming that bit's okay. Please tell me if it's not. Okay.